Welcome to August Leetcode Challenge. Today's problem is distribute candies to people. We distribute some number of candies to a row of n people in the following way. We give one candy to the first, two candies to the second, and so on until we give n candies to the last person. Then we go back to the start of the row, giving n plus one candies to the first person, so on and so forth. The process repeats itself until we run out of candies. The last person will receive all of the remaining candies, not necessarily one more than the previous gift. So we want to return an array that represents the final distribution. Here we can see we have 7 candies and 4 people. We'll give 1, 2, 3, and then we only have 1 left, so 1 at the very fourth person. Here we'll give 5, 2, 3 because we'll start off by giving 1, 2, 3, then we'll repeat to the beginning and give 4 to the first person. Then we're out of candies, so that would be our output. Before we start thinking for tricky methods, let's just think about how we would solve this if we went straightforward. Let's begin with initializing our output with a list of zeros for blank in range the number of people. So this is going to be our output. Now, if we were just to do this straightforward in the way that we would think, we would start with a loop saying while candies is greater than 0. Then we can just do a for loop, say for, let's say, I in range of number of people. We could initialize, let's say, some sort of temp variable to say how many candies are we giving per round. And we'll increase that by 1. Then we will increase the output index by this number. And then we will subtract from candies the number of candies that we just gave out. We'll also need to put in a break statement here. If candies is less than 0, then we should break. Because otherwise we will give like right here when we calculate the number of candies to give, we actually need to add the minimum between candy and candies that we still have, right? So once we're finished with that, we can just return our output. And this looks like it's working. Let's test out this example, 10.3. And this also works. So great, we've solved our problem. I assumed that this wouldn't work though because this is an O of time complexity. I did try submitting it, and to my surprise, it does get accepted. Now, usually the straightforward answer can be optimized. There's a better way to do this. Can we do better than this? And we can, using some mathematical formulas. Like the one thing you start realizing is this is a variation of Fibonacci. There's definitely mathematical equations that we can take advantage of. For instance, for every round, we could say the number of candies that we'll give out in the end is going to be what? The length of number of people, multiply that by n plus 1, and then just divide that by 2, right? That would give us the total number of candies we would give per round. And then we would actually need to add some other variables. I think it was something like number of round. It doesn't matter. The point is, it starts getting very complicated. And as I was trying to understand some of the more obscure ways to solve this, I realized it's still going to end up being an O of n time complexity. Yeah, it's going to be better than this, but it's not going to be significantly better, not like exponentially better. It might be like twice as fast, possibly. But that's not really worth me going into really trying to understand the math. So ultimately, I decided I'm not going to go into it, guys, because it feels very fake of me to like try to learn that and explain it, because I know it's something that I'll forget, I won't remember. So you know what? Just this is the solution. It works. It's fine. It's O of n time complexity, and we'll just end it at that. So Thanks for watching my channel, and remember, do not trust me, I know nothing. If you can think of a better solution, go ahead and put it in the comments. I would be happy to see them. So, thank you.